Welcome all of you. Welcome to ANIMATHS. This is another video where I shall be solving sample papers once again. Okay, the sums, as I have told you, is slightly on the difficult side. Okay, generally you will not be finding these sums in the NCERT or RS Agarwal. So this is a mix of the questions from your syllabus. So this is from sample papers for 2024 board exams. Okay, so here you'll find a mix of different topics. You'll find it from polynomials, you'll find areas related to circles. Okay, you'll find tangent theorem in circles, many more. So all my sample paper videos will be a mix. Okay, because as I'm picking them up from the sample papers, so I'm not going chapter wise in these videos. Okay, so let's see what they are. So here in this question I am given two semicircles. As you can read it in the question, there are two semicircles, and in these two semicircles, one of the semicircles is a MON and the other semicircle is the bigger one. Now in these two semicircles we are supposed to find the shaded region that you can see on top. Okay, there is you can see the shaded region. We are supposed to find the area of this shaded region. So one semicircle is here, another one is the big one. They are not intersecting, they are just touching one another over here. So the only information that has been provided to us is that the radius of the bigger semicircle is a 6 centimeter. That's all. So what we do here is we try to remember our 9th standard portions of circle theorem, where we had learned that angle in a semicircle is always a right angle. So what we do is, taking this smaller semicircle, we take this point and here we join them to the point of contact. Okay, so here this is since this one is also a semicircle, this angle becomes a 90 degree. It becomes a 90 degree. Okay, now if this angle is a 90 degree, we have a right angle triangle here. Also, again with that we have also got something else, that is MON. This thing, this full sector is a quadrant. It forms a quadrant. Okay, so we can see that this is a quadrant formed for the bigger circle. For the smaller circle we can only see a 90 degree. Okay, so here what is now this length is 6 because radius is 6, this length is also 6. So let us find area of the triangle. Which triangle? MON. Area of the triangle MON is half into 6 into 6, which is 3, which is an 18 centimeter square. Okay, so we have got this. Next thing that we need to find is the area of this quadrant. So area of the quadrant. What is the area of the quadrant? Area of the quadrant is pi r square by 4, and they have told us to leave the answer in pi. So we will, this is pi 4 and r square is a 36. So this is a 9. So finally we get a 9 pi centimeter square. So we are not going to calculate the value of 9 pi. Okay, we'll just leave it like that. Now coming to the next part. The next part is we'll have to cut out this triangle from this quadrant. Therefore, area of the segment, that is the shaded region, area of the segment is 9 pi minus 18, right? Because this is the full quadrant is 9 pi as we have got it, and this much is an 18. So it is 9 pi minus 18 centimeter square is my answer, and they have also told that get the answer in terms of pi. Okay. So what are the things we need to remember in this question? First thing, we need to remember this circle theorem. where angle in a even if it is taught in 9th standard, we have to remember it. So angle in a semicircle is a 90 degree. That is what we have to remember. The second thing that we have to remember is the area of a quadrant is pi r square by 4. That is 1/4 of a circle. So basically, with these two informations, we can get the area of the shaded region, that is area of this segment. Now if you see the second sum, now our second sum is again two semicircles, but they touch each other over here, okay, and there is a common tangent passing through them. Now this common tangent is, the name of the common tangent, if we extend it on both sides, is ST, okay. The name of the common tangent is ST, and at the point of contacts it is P and Q, okay, and then here we have M and N, that is the center of the two semicircles. The only thing that they have provided us, as you can see in the question, is radius of the two semicircles is a 9 and a 16. Smaller one is a 9 and bigger one is a 16. So what do? We can join this with the center, and here also we can join this with the center. Now we all know that, what have they asked us in the question? They have asked us the length of PQ, that is the common tangent, the part of the common tangent, that is PQ, the line segment PQ, length of PQ they have asked. Now what do? If the radius is going, and if the radius is touching the tangent, then the angle the radius and the tangent makes is always a 90 degrees. So this is always 90. Okay. Other than this, at the moment we don't have any other information. So here this is 9 and this is 16, the question has told us. So how to find PQ? There is a small construction that we will do. So just watch. I'll extend this little bit. Yes. And I shall be making a 90 degrees over here with this. This angle will be a 90 degrees. Now why is this angle? Why did I make it 90 degrees? Because I wanted to form a rectangle here. This, let me name it as X. So PXNQ forms a rectangle. Now why do you need the rectangle? How is it a rectangle? Because if this is 90 and this is 90, co-interior angles are supplementary. If co-interior angles are supplementary, these two lines are definitely parallel. Okay. Now here when I made the 90 degree, again these two lines also became parallel, because this is 90, this is 90. So I have got a parallelogram whose all angles are 90 degrees. This is also 90. Okay. So all angles of this parallelogram is a 90 degree, right? If all angles of this parallelogram forms a 90 degree, in that case we have all angles of the parallelogram is a 90 degree. In that case we have a rectangle over here. Another thing that generally doesn't catch our attention, here to here is a 9, here to here is a 16. So total MN length of MN is equal to 24. Yes, length of MN is a 24. Now I have extended this and then made a 90 degree. Now if this is a rectangle, then if this much is 16, this also has to be 16. That is PX is also 16. Then how much is MX? MX is a 7. 16 minus 9, that makes a 7. Okay. Now how much is XN? Let me find the value of XN. This is a right angle triangle. So I shall be, the hypotenuse is 25. So NX square, that is this line square, is, I can write from Pythagoras theorem, 25 square minus 7 square. That is 625 minus 49, and that gives me a 576. Isn't it? NX square is a 576. If NX square is a 576, then NX is square root of 576, which is equal to 24 centimeters. You can find this by prime factorization. So this is 24 centimeters. So here if I have a 24, if this is 24, then since P, Q, N, X is a rectangle, since this is a rectangle, therefore PQ is also equal to 24 centimeters. Okay, so these are the most compulsory steps. Okay, so even if you are in a hurry, see to it that you are writing at least this much. Okay, and you must add the centimeters over here. Unit is essential. Here you can add one step that can be added, that you can write construction and you can write draw NX perpendicular to PX. That's all. Okay, and then this is plain Pythagoras theorem being done. Okay, so this is the sum. Let's see what the next sum is. The next question says, if m and n are zeros of the polynomial 3x square minus x minus 2, if n and m are the zeros 3x square minus x minus 2, this is the polynomial we have, and m and n are the zeros, m and n are zeros, then how do we work with this? Okay, so what we have to do, if these two are the zeros of this polynomial, we already know one thing, that the relation between zeros of a polynomial and the coefficients. In the next question, they have told us 3x square minus x minus 2 is a polynomial. Okay, and m and n are the zeros of the polynomial. Okay, find the values of the following without factorizing the polynomial. Okay, so they don't want us to factorize the polynomial, but they want the values of m. They want the values of 1 by m plus 1 by n. That's one thing they want the value of. Okay, the second thing they want the value of is this, these two things. So we have to find the values of these two things without factorizing. Now if we remember the relationship between polynomials, coefficient of a polynomial and its coefficient of a polynomial and the zeros of the polynomial, then remember, sum of the coefficients, sum of the zeros is equal to minus b by a. You remember? Yes, sum was equal to minus b by a and product was equal to c by a. Okay, so this is minus b over here is a 1. Yes, and this is a 3 because b itself is a minus 1 and the formula had a minus. The next thing is and the product is how much? Product is equal to c by a, that is minus 2 by 3. Now I have what to work with. Here, if I write m 1 by m plus 1 by n, yes, if I write 1 by m plus 1 by n, which is equal to mn is the LCM, m plus n, yes, that gives me m plus n is 1 by 3 and mn is minus 2 by 3. Okay, so what do I get now? I get 1 by m plus 1 by n is coming to a minus half because this 3 and 3 will cancel. This is minus half. The second one. Okay, the second one is, what is the second one? The second one is they want us to find the value of this. Okay, so we'll use algebra here, we'll use some algebra here, that is algebra here, which is m plus n square, that is a plus b whole square, is a square plus b square plus 2mn. That gives me m plus n is a 1 by 3 square, and this will be left as it is, plus 2. Mn is minus 2 by 3, minus 2 by 3. So that gives me a minus 4 by, that gives me a minus 4 by 3. So m square plus n square minus 4 by 3, which is 1 by 9. M square plus n square is equal to 1 by 9 plus 4 by 3. Okay, that is, so it is 1 by 9 plus 4 by 3, which is equal to 1 by 9 plus 12, which is 13 by 9. So we have got both the values. The first value is m, 1 by m plus 1 by n we got as a minus half, that was the first value, and here is the second value that is wanted. We've got the value here too. This is our next sum, and in this they haven't given us much in the diagram. Only thing, they have given us one right angle triangle here, another one here, and here there's a 45 degree, here there's a 60 degree, and this question mark side we have to find. As you can see in the question, this length of PQ is a 2. The diagram in the question paper didn't have the markings, but I have marked it, because otherwise it is, if the diagram is not marked, you mark it, because it makes the sum easier for you to write when you have labeled it and you have put your ABCDs. Okay, now here if this is 45 degrees given to us, then this automatically becomes a 45 if this is 90. The triangle gets converted to a right angle isosceles triangle, therefore this is also 2. If that is true, Pn square becomes a 2 square plus 2 square, which is a 4 plus 4, which is an 8. Therefore, Pn is a root 8. Okay, we can also write it as this, 2 root 2, because 4 into 2 root over, that is 2 root 2, right? That is a 2 root 2. That is how we get it. So I am keeping this ready. This is 2 root 2. Now, the next one is, here I have this, I have to find this Pm. Let me keep it as an x. Okay. Now here I have one side, one unknown side, and one angle given to us, which is one of the standard angles that you know the value of. So let me use cos 60 is base by hypotenuse, right? That is base by hypotenuse. If it is base by hypotenuse, then in place of here cos 60, I'll write a half x 2 root 2. Yes, so x is equal to root 2 centimeters. Therefore, I have got my answer. Now here I want to tell you something. Sometimes what happens, people who write their boards, students, when it comes to some sums where one angle is given and only one side is given, it doesn't click to them that they can use trigonometry, and sometimes trigonometry is mixed up with other chapters. So suddenly it doesn't click to you that we can also use trigonometry here. So here you must use trigonometry because only one side and one angle. Probably there can also be other methods of finding the answer. In some sums, I don't see a chance in this, but then in some sums there can be other methods. But trigonometry gives you very quick answers. So go for trigonometry as long as you see the angles as 60, 30, 45, yes, or 90 and 0. These are the standard angles whose values you know. Therefore, you can very well use trigonometry for these. So, value of x is root 2. Now, let us see what the next sum is. This sum is a very special one. I consider it to be a very special one because it requires a lot of understanding. Here it is minus 5, 0. They have told a polynomial passes through these points. These are the points a polynomial passes through, and they haven't given us the polynomial. Okay, 8, 0 or 5 and minus 30. Yes, these are the 4. Okay, and they haven't given us the polynomial. Now, we have to, and then they say which of these is a factor. What are the factors, what are the options that is available to us? Let me quickly write down. The options that are available to us: A, x minus 5, they are saying. B is x minus 8. C is x plus 30. Which of these is a factors they are asking? And D is a x plus 40. So which of these is a factor of the polynomial? So how do I proceed with this question? Now, one idea you all should have clearly, that any polynomial, how do you write a polynomial? You write it like this, right? And then there's some expression over here in x. Yes, you get some expression over here in x. Okay, now remember, this is a function in x and this only is your y. Okay, this is your y. This px is only your y. So if I am drawing this polynomial in the graph, let's say this is the curve of the polynomial. It means, supposing I am writing x cube plus 7x square plus 3 plus something. Okay, something like this. Okay, this is the polynomial. I don't have a polynomial with me. The question hasn't given me a polynomial. So I am just writing it from my own. So here, what it means is, if I substitute a value of x here, I'll get a corresponding value of y, and that should be a point here. I substitute a new value of x here and I get a corresponding value of y. Okay, and all corresponding values of x and y which satisfy this equation, which equation? Y is equal to x cube plus 7x square plus 3. All corresponding values of x and y must lie on this graph. And this is what exactly these points have told. These points have told us that these 4 points lie on this, on the given polynomial, not this polynomial, on the given polynomial. That is, it passes through these 4 points. Okay. Now that much was from coordinate geometry. Okay. But then let's come to your factor theorem chapter. In factor theorem chapter, they say, if this is a factor, then if I substitute x is equal to 5 over here, I should get y is equal to 0, because remainder should be 0. So if x minus 5 is a factor, then I must get the remainder 0 if I substitute x here. Similarly, if I substitute x is equal to 8, I get a factor y. So if I go through all these given options, and if I go through this, x is equal to, here I will have to substitute x is equal to minus 30. If I substitute x is equal to minus 30, I don't even know the expression. I don't know whether the y value is going to be a 0 or not. Okay, because y is minus 30, I know, and the corresponding value is 5. Okay, but x is minus 30 or not, and if so, does it have the corresponding value y as 0? I don't know. So the only confirmed answer, similarly for this, if I put x is equal to minus 40, I don't know whether the y value is going to be 0 or not, because minus 40, 0 is not a point of the expression, point lying on the polynomial. Rather, 0 minus 40 is a point lying on the polynomial. Okay. So the only correct option out of these all 4 is this, where I know for sure, if I substitute x is equal to 8 in the given polynomial, whatever polynomial, this is not a correct polynomial, this is I have made, I repeat. Okay, so this is x is equal to 8. If I substitute in my polynomial, I know for sure that the remainder is going to come to a 0. Because why? Because when x is 8, y is 0. So this is the answer. This is definitely a factor of the given polynomial. Okay, so B is the correct option. Okay, so that's it for today in this video of sample papers. I hope you have understood the sums clearly. I have tried my best to explain the sums to you, because in quite a few sums I could see a combination of 2 chapters in one sum. Okay, so you'll have to be open to it. You cannot expect one sum only covering, or coming from one chapter. They always, I have always seen CBSE papers combining questions from different chapters. They combine concepts from different chapters and make one sum. Okay, so if you have liked the video, you can like, share and subscribe. I shall be coming up with more sample papers. So keep watching. Look out for more of my videos on sample papers. Bye then.